Good morning, good afternoon, good evening, everybody, wherever you are in the world today. Thank you for joining us. Thank you for spending another 15-20 minutes with us to go through some more capabilities within the SEER suite of estimation tools. My name is Steve Robinson. I am one of the business development guys here at Galarath, and with me as always, Keith Garland, training and support manager, and the guy who's going to walk through everything today. What we are going to focus on today is a bit more on SEER 3D. So if you have had an opportunity to view the sessions related to any of the capabilities within SEER 3D, composites, sheet metal, additive manufacturing or machining, you will have noticed that we talked about things that we call environments. And these environments are, in essence, rules files, preset rules files that you as an organization, as a user, can create to share with your user community so that it standardizes your approach and the parameter settings and other items so that every user using the same environment will get the same baseline start point for your estimate. And today, what we're going to do is spend a little bit of time going through what these environments look like, how you can interact with them, how you can make changes to them, how you can then save that information and reuse that information within future estimates. So, as I say, as usual, probably about 15-20 minutes of your time, at which point you will hopefully have a good feel for the capabilities of SEER 3D and what environments can offer. Keith, it's over to you.
Thank you, Steve. Hello, everybody. So today we're going to be starting from SEER 3D. So I've opened SEER 3D, I've loaded a component. This is just a turned, it's called a gland. So it's a little machine component. And I'll go through the process of what you normally do to create an estimate. So select the part, select the process group. It could be additive manufacturing, composite, sheet metal, or machining. So the key to today is manufacturing environments. Now, if I click here, these are manufacturing environments, some of which are just demo ones that I've done for different customers. Others are ones that we deliver standard with the model. So it's a process of looking at what we have here, and this is obviously a turned boring type process. I would select this one. It brings in rules. It sets up defaults for, it's going to be the raw stock. It's going to be alloy steel. It's going to be lathe and milling. Some of these at the bottom, it's turning on deburring by default, it's turning on tool fab design, or it's not in this case, finishing heat treatment, and rules regarding bounding box sizes, etc. It's also controlling the sequence of roughing and finishing operations that need to be done. So we can control whether we want volume rough turning, volume rough milling, or boring in this case, to decide what we want to do. So based upon our environment and our rules, a lot of this gets set up on our behalf. Things like surface finishing, general tolerancing, some of the default hole sizes for this given environment. Now, you can control this in your own environments. Now, your environment might say, we only make aluminium versions of this. So when I load this environment, I want this to default to an aluminium alloy, or your own specific material that you've loaded into SEER for manufacturing and SEER 3D. It could also be this needn't be machining. So we could say we're going to make this from additive manufacturing, and you might not have some of these processes, so you can delete them and just have the ones that you have within your facility, your machine shop, your fabrication shop, your additive shop, so that you can then build ones that reflect your machine's capability, process capability, your part families, and so on and so forth. So they're very powerful. And like Steve said, what they do is they fingerprint your organization. They allow you to estimate component families. And one of the advantages of component families within SEER 3D, you can set this up to point at a directory for a given part family, and you can have a additive manufacturer which could say turned gland aluminium, stainless, whatever you want it to be. And then you can do batch running by pointing SEER 3D to a given directory, tell it what the batch size is, tell it what the environment it is to use, and it will run down through and create estimates one at a time, and then merge them all together at the end. So it's very, very powerful. So what we're going to do today is have a look at these. We're going to have a look at what we need to do to create a new one, how to get it into this list here. I won't cover all of them. They're all going to be very similar, whether it's machining, additive, composites, and they are generic questions relating to that type of process. I will open some so you can see them, get a flavor for them, etc. So machining, turn bore, and some of the process rules that we're going to control now in SEER 3D. So get your pens ready, because this is the path you need to go to find the environment. So it's on the C drive if it's stored locally. It's under users, it's under public documents, and SEER. So in here, I've obviously got all of the SEER suite. I've got our 3D solutions, I've got our CATIA solutions, machine cost estimator, ply cost estimator, and sheet metal cost estimator, and they work from environments in exactly the same way. And another one of our sessions will be on environments within the ply cost estimator, machine cost estimator, etc. for CATIA. So obviously I've had previous versions, so I'm going to look in SEER 3D version 4, which is the latest in my list, and you'll see manufacturing environments. And then this are the 4 main processes currently available within SEER 3D: additive, composites, manufacturing, sheet metal. So if I open this one, you'll see the same list of parts that appeared here. Okay, turn bore machine, manual operations, and I'll come back here. You'll see in my list what's happened to it. Oh, I lost it. C, good revision, users, public documents, SEER 3D 4.0, manufacturing environments, machining, and that's what I was just showing you there. So look at the environments that we give you. Now, obviously the ones with company names aren't in your list. So what you would do is you'll say, I want to take an existing one. I'd say I want to take my fully automated CNC machining, for example. I'm going to right click and copy it, right click and paste it, right click and rename it. So that's the first stage. We've created a copy of one that we're happy with, or we feel is the closest fit to what we're trying to do. So this is going to be Steve Robinson. Robinson Engineering, CNC machining. We'll remove copy from the end. So this is Steve's very first environment for his organization. So we can now open this one up. And what are we seeing in here? So we have a group of files. This is the main rules environment. This is an Excel workbook containing most of the things we have to do. Also in here is a SEER for manufacturing, the .mfg file, and this contains all of the processes within that environment that will then be saved in turn as knowledge bases. And these files here are the knowledge bases that this file will create. I could actually, and I will do it, I'll just shift these. I can delete all of them if I wish to, because I'm going to create them again during today's demonstration. So the first thing I'm going to do is I'm going to go into here, double click to open it, and we'll review some of the things that are coming in to look at. So if we come to the top, The first thing we'll notice that the engineering name has been carried through. What is our default currency? Our friends in America will obviously want to leave it at US dollars. Our European colleagues will be in euros, and ourselves in the UK will change it to British pounds. What is our default material? So we can decide that for our component, we want to start from forgings, castings, raw stock, additive manufacture. Today, we're going to leave it at raw stock. Our main process is going to be milling. So this is where we can switch between milling and turning and milling. So we'll leave it at milling, and I'll change this to aluminium lithium alloys, perhaps, for a change today. Our default shape is going to be rectangular, and this is where we can change our default tolerancing for our components, and we'll make them a little bit tighter limits. Yes, we're going to deburr it. Yes, we're going to finish in heat treat. Yes, we're going to do tooling, and yes, we'll show. So these are just yes, no's. And if you remember back at the beginning, back in SEER 3D, come back to it, at the very bottom, these are the defaults. All we're doing there are turning these on or off by saying yes or no. So it's not the end of the world if you get them wrong. However, it's just there to save you time so that you know what's included within your estimate at the end. Coming down through, so this line here is important in respect that further down in the list, this is where we're going to set up our setups, our machine conditions, our process capability, setup complexities, etc. for this type of machine. And in here, it can be fully automated, semi-automated, manual operations, and so on. So we'll say it's a fully automated. The largest drill it can drill is 50 millimeters. Fillet edges 25. I won't change any of these. Bounding box. So our company standard for a bounding box we'll say is 15, 15, and make it 10. If it's round diameter, it's going to be 10, but it's not applicable because this is going to be milling only. Excess percent 10%, forging excess 5%. I'll just come down the list. And so some of these here we can change, we can review, we can look at. So we're going to be starting from raw stock, so these won't be applicable. For detailed rough milling, you can have a setup amortization. So we could say we always do batches of 25. We can say our rough milling percentage, we're taking off 20%, turning 20%, boring 20%, lapping, operator attendance factors 25%, sinter drill depth, diameter and depth, so it's quite small, we'll say it's going to be 3 and 3. Threaded holes, none. Honing, if we have honing, defaults. Cutaway stock percentages, bandsaw. You can apply SEER adjustments or not. This is the effect of learning curves, machine tool conditions, etc. Deburring rate, millimeters per minute. I was going to say we got a good man. He's going to do 3,000. Length factor. So we're going to put about 1.25. So we're going to increase the periphery by 1.25, 25% more to allow for a little bit more extra deburring, but he is going quicker, so that's okay. Anything over 12 kilograms, we're going to use a crane, and the skimming of excess stock, we can leave this to 0. So quite often within SEER, people that are familiar, 0 is going to mean let SEER do the work, let us do the calculations rather than entering defaults. So that's the top section completed. Then it comes into some of the rough stock machining ops. So we can now turn on by default whether we want to have a roughing operation for doing skimming the top surface, and we're going to do that with surface skimming rough. Will we take a finish pass? Yes, we will. We want a nice finish pass. Cutaway raw stock external, internal. Again, yes, no. We'll say yes. We'll turn everything on here in the section. So this is when you have, let's say, a triangular piece of material being cut out of a rectangular piece of flat plate. This will allow you to cut away that hypotenuse by using an end mill slot rough cutter in this case. It could be, we have other options. So you can do bandsaw, hacksaw, radial saw, etc. But we want to use a slot drill. So that's to save milling away that entire rectangle across the area. All we're going to do is going to just run a slot up there and remove that triangular using this sort of process. So we want to do some detailed rough milling and volume rough milling. Drilling, we're defaulting to using carbide drills. And again, because of the way SEER works, you can add your own drills to the ini files, and then you make that list here map to this list. So you could say I'm going to use a standard twist drill. It could be a titanium coated drill you could add to the list. But in this case, we'll leave it at carbide. What are we going to do for pocketing? We're going to use pocket rough. Profiling is going to be profile rough. And then coming over here, you'll see a lot of zeros. So these zeros basically represent let SEER do the work. Let the default values that SEER will produce, the default cutter sizes, the actual depth of cut, the radial cut, depth of cut, feed per tooth, etc., is the SEER defaults. This is where you can start to fine tune this for your, in this case, aluminium alloys or lithium alloys frames, whatever they are. So that in this case, you can say, I'm going to run this at a given surface speed. My cutter diameter is going to be 200 millimeters. It's got 12 teeth. My surface meters per minute is 400, and so on and so forth. And take full control here. Otherwise, you can do that. So if you can sit down with a machining expert, a production engineer, somebody that can help you, program manager, shop manager, foreman, charge hand, whoever it is, you can fill this in with the latest and greatest information that they currently run at. You can sit down with a tool supplier and you can use the defaults for Mr. Sandvik or Cormorant or one of the other large tool suppliers, and you can embed this sort of thing. If we were doing turning, this is the sorts of things we would be changing as well. Rough turning, detailed rough turning, volume boring, detailed boring, roughing faces, parting off, and setting the defaults again if they're applicable and if you want to change it from 0. More custom roughing operations. So again, do we want to put in tooling hose as standard? So I can say yes, I want to hold my plates down with tooling hose. They're tooling hose, and I'm going to have 4 holes, 10 millimeter diameter. The depth will be the bounding box depth, so it makes sense to leave that because the parts will vary in thickness. Profiling, are we going to do any pocket rough milling, profile rough milling? And again, we can say yes, no to this if we need to do it for the roughing. There could be instances where you have to rough a profile. There's instances where just going around with the flat cutter is good enough. So we'll leave these at no for the time being. No, actually, I'm going to turn on profile rough milling. Yes, so I need to make some changes just because I can. Surface finish machining. So what are we doing for the machine surface? So we're using end mill finish for all of these processes, and for any bored holes, we're using bore finish. And again, we can come in here and we can change these cutter default surface speeds, RPM, feet per tooth, actual depth of cut, etc., to satisfy our machine shop and so on. Finish turning operations, again, they're all defaulting to yes. What are they? Both turning and milling for that. The holes, so in this one, for hole drilling operations, if there's none, it's not applicable. For through holes, we're using carbide. Blind holes, carbide. Flat bottom holes, we're using flat bottom drills. Countersinks all make sense. And again, we can change the defaults if they're applicable. So these are the drill types. So they can be added to match your ini file here. And again, you can put other defaults in here to speed things up, slow them down accordingly. Now we're coming into some of the specifics relating to the cutters. So we can start to control what the cutter selections are. So if we have a 100 mil cutter, it's got 7 teeth, a 6 millimeter actual depth of cut, 60 mil radial depth of cut. And again, you can manipulate these to suit your tooling, that you supply to the shops, the number of teeth, actual depth of cut for that given material, and so on. So we do that for face mills, end mills, angled faces, carbide, threading operations. Okay, so if there's none, it's not going to do anything. Tapping, it's going to be turned on. Thread milling if it's an internal. Surface. So this is to do with surface finishes. So if you change a surface finish by default, it's going to turn on grinding, or it may turn on grinding and honing. So you can control those processes that go there. Same for surface machining tolerances. So if it's 0.1, it's going to be finished machined. If it's 0.05, we're going to add a grinding operation. And then if it's 0.05 for grinding and lapping. So you can change this if you wish to. Hole tolerances. So again, a 0.1 is just going to be center drill and drill by default. This one is going to be center drill, drill and bore, and so on. This is the table that relates to, at the top I said to it's important. So up here, we said it was going to be fully CNC selected here. If I come down to that table again, this is the table that it's reading for that given processes. So this is controlling all of the setup. So it's saying cutaway raw stock will have a setup, volume rough milling will have a setup, volume rough turning. So it may be applicable, but I'm going to do this. I'm going to say no to everything, and I'm going to turn them on myself where I see fit. So they're all no's, and now I'm just going to come back, and I would look at this and think, skimming excess stock is a yes. We're going to load it, we're going to unload it, and we're going to mill it. For doing volume rough milling, we're going to have a setup. We're putting on the big NC machine and setting it, and so on. We may find that what can we do? High-speed machining ops, would that be a setup? Maybe. Or we could say that our bored holes may have to go onto a horizontal bore or a vertical bore. So we'll give them a setup as well. And that's all the setup I'm going to give them. Down here, the same columns are setup complexity. I think that's overrating it, because probably this is going to be done as a background operation. So the setup time will be lower. Machine tool condition, I would hope it's going to be good, as this one is. Process capability, it's going to be good. And you can do this as form of calibration. And you'll see we have another video on calibrating SEER for manufacture and some of the things. And one of the things we look at is the machine tool condition, setup complexity, machine process capability, and that's well worth watching as well. For the process finishes down here, we have air gun spraying, and these percentages are of our component. What percentage are we likely to have to paint? Now, I think we're going to have to paint this one 0.95. 95% of it's going to be painted by default. Plating is 100%, e-coating, and so on. So you can solvent clean. I want to clean 100% as well. And that's going to go forward, and we'll come to that in a minute when we look at the knowledge bases. This is just a material listing, some of the densities as in the INI file, and then this is a table where you can add your own materials, use our materials, and be very specific now. Surface speed, finish milling speed, rough mill, feet per tooth, all the way across, so that you have this great ability to fine-tune the model even further to map to your conditions within your machine shop, etc. Okay, so that's basically it. We've come to the bottom. I'm going to just simply do a standard save now, come back to our folder, and why does it keep disappearing? So it's C, users, public documents, SEER, SEER 3D 4.0, manufacturing environments, machining, Steve Robinson machining, and the knowledge base file. So this is a standard SEER for manufacturing file. We'll open that one next. So this is going to contain a work element of each type that belongs with that environment. They're specific to the environment. And as it opens, we'll see we have finish and heat treatments, forgings, machining, castings, etc. So in this one, I'm just going to go into my, move my menu out the way, options, set project parameters. I'm just going to ensure that everything I want is current. This is the last job I done was an old one. Latest inflation tables. I want to be British pounds. I just want it to map what I'm doing. I'm doing latest mapping database, my precision. I'm working in metric. You can obviously work in imperial. I could work in multiple currency. Click on OK, and then I'll go save configuration, to map that and save it. So in the machining ops, you'll notice that each one of these now has notes. So they're there to guide us. So input values set via the CAD interface. So when we run CD, we tell it the quantity. We tell it the setup amortization quantity, and we put in a given value. Tooling amortization quantity again, setup. So we can change the labor rate, or I'll just leave these at standard default labor rates. I want to increase the settings. So, right, so I want to say my guys are good. We got a fully NC machine. My product classification is I'm doing commercial vehicles. So it's not always aerospace. We can do what you like within SEER. So we're going to set that one lower. I'm going to leave that at 1.1. So I'm going to give it 10% for maybe a bit of rest and recreation. I'm doing my process steps, 95% curve. I'm comfortable with that. Process specifics, then much of this is coming in from the 3D geometry. So the aluminium alloys will be coming in from the interface. The part sizes will come in from the interfaces. And here, operations based on mapping to surface types in SEER 3D. This one we looked at, that was at the bottom, that's set by the interface as well. So there isn't a lot we can do, with the exception of maybe we can create a tool list here. So in this case, we've got a checking fixture, a profile fixture. We could add some machine control medium for a machine part. And click that. So we've added that to our tooling list. These things here, what I tend to do, if I've changed them, I can come along, just copy that section, copy, because it's only a few, I can paste them in here very quickly, just to make sure they're common across all of my different parts. Finish and heat treatment. So within finish and heat treatment, this is the list it's going to do. So it's going to automatically pick up the part sizes, which will populate this. So it's going to do abrasive blasting, solvent cleaning, painting. And I'm going to say I don't need abrasive blasting. And that's it. So that's that one set. So now I'm just going to quickly save this one. That's my environment settings done. I'm going to close it. And I'm going to come back to this file here. And at the top, you'll see we have a little macro button. Click on the environment. So this is saying update and save my SEER MSG knowledge bases, save the text rules file, and click OK. So now that's going to go off. It's going to reopen that SEER for manufacturing file I just closed. It's going to go through a list. It's going to open each file and save it as a knowledge base. So it'll do that one at a time for each line item within that file. It will then save itself, save the knowledge bases, and are ready for use. Click on OK. And I have no clue why that shuts every time. C, users, public documents, SEER 4.0, manufacturing environments, machining, Steve's. And there they are. All of the knowledge bases have been recreated, ready for use with this specific environment. So I will close at this time. I will just come away from this one, come back to SEER 3D. And what I can do now is come back to the top, deselect machining, select another one, go back, select machining, and Steve's is in here. It's ready for use. So I can put my 1,000 components in. 25 as default, aluminium lithium alloys. So it's the wrong type of part, but it doesn't matter. I'm just showing you that we've got our skimming excess stock cut away, etc., etc. Surface finish operations, 0.1, hose and tolerance thing. I didn't do anything to them. So you can come into this one and you can obviously change this to, let's make it tapped hose for all of them. And that's that. And then obviously you can run, this is going to be totally wrong because it's doing all milling on a turn part, but the theory is the same. I'm not sure if that, there we go. So that will run now. The environment will set and create a part, milling that complete, strangely. Going back to here, there's the file, done our machining. You've got all of our operation details, the environment worked. It's been a very strange milled component, but anyway, it worked. That was the main thing. It didn't matter what the part was. Come back to here, users, public documents, SEER, SEER 3D 4.0, environments, composites. So I could just open one of these and you'll see we have all the knowledge bases. We have a manufacturing MFG file. We have a environment editor, enable content. So this is obviously questions relating to composites, defaults, default materials, debulking intervals, process rules, and all the things you would expect relating to composites. And these are all the things in this one here. So it's different questions, same theory, okay? This is setting complexities, this is setting the materials or density, etc. I open another one, we'll close that one. See, users, public documents, SEER 4.0. Additive. There we go. So these now are all the questions relating to additive manufacturer, print resolutions, jetting materials, binder materials, PBF, DED materials, SLA, and all of the information that you need to know to set up an environment. So they're subtly different, but the same theory. Each environment will have an Excel workbook with a list of questions and rules which you can control. Each environment will have a SEER for manufacturing file that you can edit, which will create new environments specific to that given environment. Once you've done a generic one, you can then copy that, you can refine it, you can tweak it, you can do them for part families, you can do them for different suppliers, you can do them whatever you wanted to. So that, I hope, is a quick overview, a little bit of guidance into setting up manufacturing environments, where to find them, the sorts of questions it's going to ask you, the process steps that you need to follow to do that. Once you've done one, then the second one's going to be a lot easier because you'll have many of the parameters set that'll be specific to your existing processes, your existing options, and then they'll all become variations on that original one. I think that's probably all I need to show you for today. I'll just pass you back to Steve, and once again, thank you very much for your time.
Thank you, Keith. Thanks very much for that. As Keith said, there's a lot, as you can tell, there's a lot involved in all of that, and we have focused specifically on machining, just as an example. If you have particular questions with regard to any of the other processes, so composites, additive manufacturing, or sheet metal, please get in touch with us. Our details are on the screen. Please get in touch with us, and we will happily guide you through those particular environments and the particular questions that you may have. We'd be more than happy to do that. So as we said at the beginning, the whole concept of these environments is to standardize regularly used data processes and parameter settings so that everybody is singing off the same hymn sheet. It just leaves me to thank everybody for their time today. Thank Keith for his time as well. We will continue these series of short sessions over the next foreseeable future. Please, if you've got any suggested topics, send us over an email, and we will endeavour to include that in the list of things to do. So thank you very much for your time, and we will see you at the next one. Thank you very much.
Thank you, Steve.